Given the vector a with magnitude a equals 5.0 and a y component of a sub y is equal to 4.0, what are the possible values for the x component of this vector? Now, we had some formulas on the key concepts page that we could start with this question, but I like to use the component triangle concept for these kind of questions and start by drawing a little sketch of that. So if I say, hey, here is a possible representation or possible picture, maybe I should say, of this vector a, and this represents its magnitude a, which we know is equal to 5. And this is a purely, I think, math example, because if this were a physically relevant vector, I would probably say some units, right? Maybe if it were representing a displacement, maybe it would have been 5 centimeters, right? And the component could be 4 centimeters perhaps. But I'm just going to draw that component triangle here. So I'm going to draw the two components for a vector like this. So here are those two components. So this one is a sub x, which is, I think, what I'm being asked about. And here is a sub y. And the relationship that holds for this triangle that maybe is a little different than the one on the key concepts page, I was focused more on like, well, if you have a sub x, a sub y, how do you get a? But this one we're saying here, I'm giving you a and I'm giving you a sub y. How do you find a sub x? That's a little bit of a different question. So I'm just going to look at the Pythagorean theorem for this triangle and write that as a statement here, which really is like one of the formulas on the key concepts page, just squared on both sides. And then based on this, I'm going to try to solve for a sub x. So a sub x squared, I think if I subtract a sub y squared from both sides, should be equal to a squared minus, minus a sub y squared. And so if I square root both sides, I would get a is equal to the square root of a squared minus a y squared. I want to mention sometimes I deliberately make a mistake, so maybe look at that closely and decide if I've made a mistake there. But let's just carry on for a second and see what happens, because I think at this point I'm ready to just put in some of those numbers right there. I know that a is given to me as 5, so I'm just going to say 5 squared. A sub y is given to me as 4, so I'm just going to say 4 squared. So 5 squared minus 4 squared. And let me see, that's going to be equal to 25 minus 16, which, oh, isn't that kind of cool? That's just equal to the square root, because that's equal to 9. And that in turn is equal to 3. Now, what mistake did I make here? I think I did get a correct answer, but it says what are the possible values for the x component of this vector. So one of the things that I've neglected in this math is the possibility of, like, what if this vector actually points in a different direction that still has maybe the same y component, right? So it could have a y component of 4 right there, but maybe its x component, could it have been negative 3? In other words, could this be possible? 5, 4, but this is like a minus 3 component. And my answer is yes. And the way that that escaped my notice in the math is when I square root both sides, I should put a plus or minus. But I'm very picture oriented, very concepts oriented, and I encourage people in this class to think about adding that to their repertoire, even if you're maybe a little more algebraic than I am, and that's great. So I think about, like, well, what else would make sense? And I realized there was another vector that kind of makes sense, and that kind of explains the math mistake that I made, that I forgot about the possibility that this could also have been a negative 3. Oops, I forgot to put the x here. A sub x component. So plus or minus 3 are the answers I'm sticking with here, and there it is.